Let me give you the example, okay? Guys, whenever you study and you have to know why we have to learn this or we have to practice this kind of example, okay? We are talking about the spring motion and we are talking about undamped free vibration, okay? Undamped free vibration means there's no external force and there's no damping term, right? So, well, like as you understand, like no external force and no damping term means your solution curve will be just oscillation forever with the same period and same amplitude, right? That's it, okay? So, like the benefit of like this example is like is what? Like, like it is like 4 cosine and minus 6 sine form, right? But like with this form, and it is not easy to find amplitude and period and frequency and phase everything, right? But if you can combine this one as one single trig function, which is cosine, then you can find everything easily. Okay, that's what I said. Okay, so we would like talk about all those things. Okay, so in the previous slide, I gave you one formula, right? What was it? If you have a, okay, let me scroll down a little bit and I'm gonna have more space. A cosine omega t plus b sine omega t form, then we can change this one as r cosine omega t minus delta form, where your r is equal to square root of a squared plus b squared, and tangent delta is b over a. But also keep that in mind. Your b came from r sine delta, and a came from r cosine delta. Is okay? And if you understand like this one, if you like know about this one, you can do everything. Okay. Now let's try to practice how we can combine sine plus cosine form as one single trig function cosine. Okay. Here we go. So here we go. Then this one can be written by square root of 4 squared plus minus 6 squared times cosine of your omega is 7 for this case, and 70 minus delta, right? And then, like when you simplify this one, it is equal to 16 and 36 cosine 70 minus delta. Let me take a delta later, okay? But let me take a r first, okay? That is equal to, what is it? Square root of 4052 cosine, bad writing, delta. Then since square root of 52 is 4 times 13, right? 4 times 13, which is 2 square root 13 cosine 70 minus delta. Okay, so this 2 square root of 13 is your r. Then what is delta then? Where your delta, not delta, but like let's start from tangent delta, okay, is equal to b over a, which is my b is negative 6 over 4, right? But wait a minute. Your delta must be from 0 to 2 pi, right? Okay, do you remember? I said like b came from r sine delta and a came from r cosine delta, right? And for this case, your b is minus 6, okay? Then, okay, your sine value, since r is positive, then sine delta is negative now. Sine delta is negative means your delta must be in the third quadrant or fourth quadrant. Does it make sense? Okay. And what about your denominator? It is consonant with the sign of cosine, right? Cosine delta is positive, which means your delta must be in the first quadrant or fourth quadrant, right? Which is the intersection between these two. That is the fourth quadrant, okay? And we know your delta must be in the fourth quadrant. Does it make sense? So, okay, so let me finish this one, okay? The mod delta must be in the fourth quadrant. Then keep that in mind. Inverse string function will give you the reference angle only, which is between 0 to 90, right? So to put that in the first quadrant, and your delta must be equal to 2 pi minus arctangent of minus 3 over 2, which is negative 6 over 4. Does it make sense? Okay, so my answer is your r must be equal to 2 square root of 13, and your delta must be equal to 2 pi minus tangent inverse of minus 3 over 2. Is it okay? Let me give you one more problem, okay? It is quite easy, okay? But again, you have to know the purpose of this one, okay? And we would like to talk about the frequency and period and amplitude and phase of the solution curve, okay? So let me give you one more, okay? Here we go. You see? Coefficient cosine is A and coefficient of sine is B, right? Then we can write this directly, okay? This will be written by directly R cosine delta T, oh, delta, no, give me a second, not delta, omega, right? Omega is 9 pi and minus delta, where your R is equal to square root of A squared plus B squared, which is equal to square root of negative 2 squared plus square, okay? That is equal to square root of 4 plus 3. Then that is just like square root of 7, right? And then what about your delta, right? Your delta must be, okay, there we go. Tangent delta is B over A, which is B is square root of 3 over minus 2, right? But okay, do you remember? Like your B came from R sine delta, and your A came from R cosine delta, right? And then think about it. Your sine delta is positive, right? Which means your delta must be in the first quadrant or second quadrant, right? And your cosine delta is negative now. That means your delta must be in the second quadrant or third quadrant, right? Intersection is the second, right? So my conclusion is your delta must be in second quadrant, right? And then now let's use the reference angle, okay? So your reference angle is like tangent delta is equal to square root 3 over 2 without sine, right? And we're gonna put that in the second quadrant. How can we read? Your delta must be equal to pi minus arctangent of, right? Like you understand what I'm saying, right? Tangent inverse of like square root 3 over 2 will be the reference angle for the negative square root 3 over 2. And then we just subtract with like from the pi, then we can put your angle delta in the second quadrant, okay?